protect your soul.
All right, all right. How's everybody this Sunday? Doing all right? Already see some folks in the chat. That's awesome. Thanks for showing up today. Let me move this chair real quick. All right, today we're going to continue on with the box turtle. Seeing thumbs up in the chat. Thanks, Rob. All good from Boothie. Love it. Yeah, continuing on with the box turtle today. We got a little bit of work done on the stream yesterday. Not for the box turtle, but for streaming setup purposes and making things much nicer than they have been. So synced up with my buddy Jeremy. He kind of walked me through a lot of the things. We went through some settings and all that stuff. So hopefully much nicer product for you all this time, and we can follow along and get some stuff done. For us, we're here until we're not here. So there's no real plan today for how long we're going to stream or what exactly we're going to do. I have a general idea, and we're just going to go with the flow. So you guys control the chat. You guys control the stream for today. Let me know what you want to see and what we should do next, and participate. So we'll get through this one together. My ultimate goal is to tear apart the stealth burner on the Trident, update that for box turtle. So I have some parts printed out. We'll get through the heat inserts on that one, and we'll take a look at Filamatrix and see the work that Thunder Keys has put together. So that's the general idea of what we're going to get done. That may involve some soldering, that may involve some clipper config and whatnot. I'll tell you, the config on the Trident is jacked up. It is not working correctly, and I have a feeling I'm going to have to wipe that and start over. So if we end up down that road, we'll see. We'll see. Otherwise, how's everybody doing? Getting a little warm in here. I'm going to turn this down. I did end up putting that heater out here because in the mornings it's about 35 degrees Fahrenheit out here. So down close to about 2 or 3 C in the mornings. But in the afternoons it's mid 70s. So we have like a 40-degree swing from night to day. All right, I think what I'll do first is give you a little bit of a tour on what we're doing as far as the stream setup, things that I improved yesterday. And you guys give me thumbs up or not, whether or not we've made some good moves. So number one, you're noticing a different kind of a theme and scheme back here. Hey, Will, yeah, 3C is your summer. I would love 3C year round, so maybe Canada is the next move. We'll see what happens. Yeah, so we did a little bit of an update on the theme here. So you're seeing more of a, I don't know, graffiti style. We updated the chat so it's a little easier to read on screen. I was having a hard time seeing it, so I was missing your comments and your questions and things like that. So it's a little easier for me to see that. But a quick tour. So first we did an update on the PC. So you're looking down now. We did an update on the PC, and so I'm gonna manually turn the camera here. You're seeing a monitor. So we added a monitor to the stream. This one was, I don't know, 50 bucks or so. Not very expensive monitor, but something that works here so that we can see what's going on. And then we added, if I can get it in frame, I cannot. Just out of frame there is a new mini PC that controls the stream. So Boothie, you're saying it's much sharper. I appreciate that. That's probably due to the resource limitations that I was getting on my Surface Pro. So now with the mini PC, we're able to do that. It's got a pretty decent processor in there, a lot of memory and RAM, and so produces much a better product. Next, you'll notice we got the Stream Deck, so I'm able to flip and go back and forth. So we'll get into some cool streamer effects here in a little bit. But yeah, it's working out pretty well. And then of course we have the phone that I can monitor chat if I need to. So to continue on, these are the parts that we printed. This is what we're going to need for what is it, the Filametrix. Sorry, that name is hard for me to say. I keep thinking of the Filametrix, which is the older one. You want Filametrix, which is the new one. So we have the new Rapido Ultra High Flow V2. Rapido Ultra High Flow V2 parts. And those are gonna be what we need to update the Trident. It does run a Rapido on it now. So we got both parts for that hot end, and we'll have to swap over. I even printed the small PTFE2 cutter so we get the right length that we need. And then it does recommend, Filametrix does recommend that you use a stealth burner on it. I don't like the stealth burner. I'm sorry, the Clockwork 2. The Clockwork 2 is the recommended extruder for this. I honestly prefer the Galileo 2, so those are the parts that I printed is for the Galileo 2. That's also what's installed on it already, so I want to reuse a lot of those parts. Printed the beefy arms, so this should be the lever that presses to be able to cut the filament. One thing I did miss though was the blades, so I do need to order some blades on Amazon later today so that we can actually use that. But I wasn't sure which kind I needed, so I just printed both of the parts for the 2 different blades that you're able to use, and we'll figure out which one fits the best. Struggle with the GT2 with the box turtle? How so, Boothie? What happened? I'm not sure what the... Are you saying Galileo 2 when you say GT2? Is that what you mean? I think that's what you mean. Hey, what's up, Canuck Labs? Welcome into the chats. We're finishing the box turtle-ish today. I still need to do wiring. I need to flash boards, all of that stuff. So hopefully we'll get through some of that with your help. But right now, I think we're going to tear apart the stealth burner and get that good to go. Right now, I'm having a trouble with the Trident actually connecting the clipper. For whatever reason, I cannot flash clipper to the board, so I may have to pull out the SD card and do it that way. Did I pay for the box turtle? I did. It is a kind of a self-source kit. I don't know that I have any of the packaging from the folks I bought it from. Here we go. Actually, I do. So this is the company on AliExpress that I use. There we go. Some focus. C-Lead Lab. If you go to their AliExpress store, you'll be able to find a box turtle kind of hardware kit. That's what I got. It came with a bunch of bags of hardware and then 8 extrusions. Yeah, 8 extrusions. So a kit kind of, but not really. All of the wiring had to be handmade and shortened and crimped and soldered and all that stuff. And so, yeah. I don't know if you can trust it or not. The parts that came in it worked for me. They weren't off or crappy quality in my opinion. It seemed fine. It's just hardware like screws and bolts and whatnot. No tension stop on the GT2. Boothie, I think that's... So if I look inside here, you would put a heat set here. Come on, focus. There we go. You'd put a heat set here, and then I want to say there's a flathead screw in there, and that flathead screw provides the tension. So I think that's how the the Galileo works. We'd have to look at the docs when we get there. But I also just noticed that I don't know if I have a 5.5mm ball. I know I got some 5s somewhere. So I may have to find those in a bit. But we'll get through it. And then also, I was printing parts this morning for the Turtleneck 2.0. Come on. Turtleneck 2.0. So this one is a hardware kit. I want to say I got this from Armored Turtle. Armored Turtle. And then it does have the long USB cable. We're probably going to use that. It comes with what was billed as a prototype quiet motor. So that one's there. The specs on this one look to be 6-volt 500. That's the only numbers I see on this. So we may have to do that. And then it came with a little bit of hardware that you're going to need to assemble the thing. There's some NeoPixels in there, some ECAS fittings, and some connections. There's also a little bit of felt tape in there. And I do remember from the manual that's part of it. And then it came with the extra controller board you're going to need. Boothie, you're saying you found the GT2 difficult to feed filament with no tension adjustment. Okay. And then you missed something on your box turtle, on your LDO kit. I don't know. That's a feature of Galileo 2 altogether. I don't know that it would depend on the LDO kit or not. I'm getting phone calls right now. Get rid of that. Yeah, you talked to one of the devs before? Yeah, I did too. I met Armored Turtle at Remurf last year. And it's a good project. Good morning, Keela. Yeah, so this is the Turtleneck 2.0 MCU that it comes with. So this would be the AFC Lite add-on. So you get a few more outputs on it, but it is another board to flash. So we'll have to go through all of that stuff. If you're looking for where to get information on it, it's printed onto the board itself. So Robert is the designer of all that. Why do your Chinese comrades take so long to respond? I don't know, man. I don't know. They're 13 hours or so ahead of everybody, so maybe they're sleeping. And then we'll keep this out because we'll probably need that. So if we get to turtleneck today, great. If not, yeah, we'll see. Cool. So let me flip you guys around to what we're going to be working on. Take you over to the Trident here. So this is my Trident. It was working at one point, and then it just kind of wasn't. Originally I had a CB2 in here, so the big Tree Tech version of the Pi, and that worked okay. But what I was getting is about an hour or so into any print, it would just lose connection, like the board was overloaded or something like that. And so it was just not working out. Flipped it over to a Pi CM4 and initially didn't have any issues. But at some point the Pi stopped talking, it dropped Clipper. I don't really know what happened to that, but it's not really working anymore. So before I can even get the main box turtle working, I need to flash the board, but I can't really do that if it won't talk to the printer. So I need to talk to the printer, and I'm still trying to figure that out. So we might get there today, and hopefully the hive mind can get us across the finish line. But right now, we'll just press with taking apart the tool head itself. So I'm gonna go ahead and shut this guy down, and then we'll see if that gets us what we need. And I realize I'm just gonna turn the power off on this, but at this point, it doesn't matter if we corrupt the SD card. I just don't want to break anything when I plug and unplug. Let's take the click-clack door off. I love that door, by the way. If you haven't done the click-clack door mod on your Trident, you're really missing out. That thing is awesome. It makes taking the door on and off super easy. I just lifted it off of there. And it didn't come with it, but I got these really nice panels from Happy with my serial engraved into the front. So he did that for me, and then he put my logo there, even though it's a little bit sideways because I have to hold it that way. He did a great job. So if you're looking for custom panels like this, reach out to Happy Manufacturing and he can hook you up with whatever you need. That panel for me, I think it was like 20 bucks with shipping and whatnot. So super affordable, super obtainable from Happy Manufacturing. All right, first we'll unplug the board. Let's see if we can get some more light in there for you all. Yeah, here's a light. Let's do it this way. There we go. We'll just add our Harbor Freight light on there so we can actually see what's happening. Curious, do your HP points ever go down? They go down if you like and subscribe. So the more likes and subscribers that we get, I take a hit and somebody else becomes stream boss. So tell your friends, tell your buddies to get in here. Yeah, I love all the panels I got from Happy as well. So this kit actually came with all the panels and everything you need to make the Trident enclosed. So I didn't necessarily need it. And then also this kit came with the standard boron front doors. I chose to put the click-clack door on the front. And that meant that I needed a new panel for the front door. I also chose to use a Trident Easy Bake frame. So the frame on this thing is a lot different than a normal Trident. For example, I'll manually show you a tour of the printer here. Let's turn this around. You can see that at the back, this extrusion would normally be a 2020, it's on this printer, it's a 4040. So it's much more beefy here. Your front panel, I'm sorry, your front upright extrusions, these here, these are a 2040. So it's much larger in the front. And that is why this one is more stout. I figured it made sense because this is an all-wheel drive configuration. So you do have the rear motor here, so the B motor, and then you have another front A motor here. This is motor 4, and then of course at the back is the other motor there. So it's all-wheel drive. I figured this one the most would benefit from a full frame. So we put the Easy Bake on it, and honestly everything fit. There was no issues adding an Easy Bake frame. It was much easier because I was starting that way. I think if you had to tear down your entire machine and then try to go to an Easy Bake frame, that would be a lot bigger task. But this one, starting from scratch, was easy. And I have something connected. What is that? I think that's my LED. No, that was my can, sorry. Yeah, so I was running a can for the cartographer that's on here, and I dropped a screw somewhere. I'm going to need that. Yeah, I have no idea where that thing went. Oh, there we go. There's too many things on the floor. We'll try to keep all that together. You got me on the big screen just waking up? Man, I feel special, Jerry. I tried to catch yours last night, but I was a little bit too late before I got to you. It's still not in my brain to check out your stream, and I apologize for that. I will suck less one day. All right, I think I had secured those down a little bit to hold that hot end in there. Loosen that up just a touch. And that should come out. That was close, almost lost it. All right, like I said, this does run the Rapido 2, and I plan to use that again. Still got a bit of filament in there. Well, that's okay. I did have to extend the wires. That's why you're seeing the heat shrink tubes here. I need to get my big fingers in there. All right, so we're gonna move this just a little bit. I gotta be able to see how that's connected back there. I don't remember. I wanna say it's on a Molex, and there it is. And then we have the thermistor. That's one of the things I really like about having these tool headboards, is that things are plug and play. So if you need to service it, it's a couple of plugs and things just come apart. Yeah. So come back to the desk here. So this is the old one. So this one would be the Rapido version. The Rapido version, and it does run the PT1000 thermistor, and it does have the Rapido 2 inside there. So you can see that these are not much different at all. Really where you're getting into differences is how the top piece is here. Here it's all integrated into the front hot end housing. Over here on the original, it is split between the two. So the back and the front connect to the hot end. Probably for rigidity, keeps both parts more rigid. But over here, you kind of need this to be one piece so that when I drop that heat set in there and actually actuate the cutter, that we get a smooth, clean cut. So that's what we got. The detail I showed on the G printed part is for the spring tension arm. I cannot see any way to stop crushing the filament with a stop that I can see. Well, as soon as we take this apart, hopefully it'll show you what you need to see. I need to cut a couple zip ties over there, but hopefully we can figure out a reason. If anybody can point us in the right direction in the chat, if you know a way to tension the Galileo without crushing the filament, let us know. I have only used the Galileo on this machine and one other, and to be honest, the other one that I'm using it on has been out of commission for about a year now. So I put it on, it was kind of working. I started modding more things, like I always do, and I jacked it up. So I got frustrated, I walked away, and I haven't been back. Life's been crazy. So we moved, and that printer never really got back to printing. So, as is life. So right now I'm just taking the in stop out of here. I try not to pull on the wires because I don't want to recrimp that or break those terminals in there. But this one is being a pain. That's one of the downsides that I don't like about the big Zyltech stuff, is it is using these very small connections. And even with that, right, you can see that the housing came off, the housing itself came off of the board. So that tells me that that connection is like super tight in there, and it doesn't really need to be that tight, especially if I'm pulling the connections off the board like that. That's way too tight. So I just tried to loosen that, and it will come back to taking that apart. But a couple zip ties. You're gonna build your 2.4 with Glow ABS from Polymaker. Canuck Labs. This one is actually made with Glow ABS from Inland, so it does glow green. These parts that I printed, these here, are printed in the same color, so they should glow green as well. I'm not going to turn the lights off in the garage to be able to see that, but take my word for it, they are glow in the dark. Haven't used the Galileo yet, so you're not sure. Yeah, like I said, this is the second one that I built. I had it working on the first one, no issues at all, worked much better than the Clockwork 2 for me, in my opinion. And then that printer went down and I haven't used it in almost a year, or roughly a year. I need cutters. These purchased one especially for the box turtle and then gave up. Yeah, I remember talking to you about that. I still don't understand the challenge. Maybe I'll find out firsthand, and you and I will understand one another a little better. But at the moment, I don't see how it's a challenge. Yeah, these zip ties, I think I did an extra great job on it because those are hard to get after. So I did make one mistake when I built this thing. I was cutting zip ties like I'm doing right now, and I actually caught one of the motor wires and I snipped it, and it was super short. And I thought I was screwed. So now I'm super careful about doing any of that. I was able to solder that wire back together and make it right, but it was such a pain to be able to do that. Cool. I think we have everything free. This should be ready to come out of here. Again, I like the modularity of this design, even though it does weigh a little more than other things. I know that's the big deal now. People want to have something that's super lightweight so we can go super fast, and that's great. I have a few pretty quick machines that use lightweight components, but for this guy, I don't know that it's necessary, especially with the Quad XY motors on there. You're gonna get enough speed regardless of the weight, simply on having 4 motors. Okay, I think we are free. I should be able to pull that out of there. Yeah. And that's the cool thing about this one, is I can just take 2 screws out of the extruder, it comes off, 2 screws out of the hot end assembly, it comes off, and then 4 screws on the face. So 8 total, and the whole hot end comes apart. But because I'm using that CNC bracket, my belt tension stays the same. So I didn't change any belt tension by taking that all apart just now. My in-stop's on there, cartographer stays, and things are the same as they always were. So realistically, if I did not have that tool board on there, I could make this printer move as it is, even without the hot end. Because I run Calico on almost all of my machines, I can set that tool head board as a non-critical MCU, and it won't throw an error code in Clipper yelling at me about, it won't yell at me about not having connection. One of the benefits of using, let's say, more power. So JPP, it's already running, it's got a Manta V2 with 48 volts. So if I can flip back to the printer, show you what I'm talking about. May have to manually move this, and I don't know, I can show you down below the bed. It's just out of frame, but let's turn the slide off. But down in here, let me see. I'll give you the face cam real quick. We'll move this around, and I'll show you with a different cam. So if I look down inside, you'll notice that it's running the what's it called? The Zyltech inverted electronics. So everything is accessible. I just lift up the bottom panel and take it out. It's running the single PSU, but on the far side, that is over here, you can kind of see the mellow, it's called a volt up board. I apologize, that's not the best quality video, but it's running a volt up board that takes 24 volt and puts it back to 48, so it kind of steps it up. And as long as you have the wattage, that's a 350 watt mean well, as long as you have the wattage on your PSU, it should work just fine. So there are 5160s in there and 48 volt. I got all the power I need to run 4 motors. So that is that. So that's how I set mine up. Booty says he's currently adding flange bearings to the spooler frames. Well overdue. I think you're talking about your custom box turtle, which is amazing. If you guys have not seen what Jason put out on Twitter the last couple of days, I think starting yesterday, he is featuring Booty's box turtle, which is completely custom. It takes the LDO kit and puts his own spin on it to where it's a little more visually pleasing. So not so boxy turtle is what he's calling it. And it's pretty cool. He did a lot of custom work on it, a lot of custom parts, and a lot of custom design. So I had to take that jacket off. It's getting warm in here after a while. Let's see. You say auto feeding filament through the GT2 compared to manual insertion. Is that because you were having trouble with it extruding? Oh, your G2 is built as a wristwatch G2, Rob? I need to do that for my, what's that thing called? A micron. I need to do that for my micron. All right. So here is the extruder itself. We're going to blast this apart, flip over to the Filametrix manual, which they have added as part of the box turtle manual now. So you can go to armorturtle.xyz and build your box turtle, your calibration fidget thing. You can build the Filametrix from there, and then also the turtleneck, which is the filament buffer on the back side of that. So I'm gonna blast this apart as we go. Let me grab a tray, keep track of all the things. And no, I did not print this specifically for this build. This is just one of the 4 that I have that I use and recycle for every build. All right, let's pull out this. Yeah, I'm pretty upset that that fitting came off. came off of the end stop here. I need to re-put that on before I forget which direction it was correctly supposed to be. And I want to say that I kind of broke it, so I may need to just find a new one anyway. That sucks. You say another equivalent would be no replacement for displacement? Yeah, I think so in the car world. I do a lot of, well, I used to do a lot of car stuff. I think last stream we were talking about my GTR, and I did a lot of work on that thing and then ended up selling it. I have a GTI now from VW, and I want to do some stuff to that, but it's under warranty, so I don't want to invalidate the warranty already. All right, I was able to get that off, even though I did break it a little bit. It's fine. We'll hot glue it if we have to. But yeah, it pulled the housing right off the pins. That can't be good. But we got it back on, so that's a positive. Just about to say, don't forget which direction. Yeah, that's why I wanted to do it now before I forgot. I still had it in my brain. We can always verify the pin out too. It usually shows the direction of how those pins should go. So I'll check that later, but it is good to go now. I did one thing I want to note, like I did have to flip the switches on this one for the first time. I've never had to do that on any of the other boards that I've built. Come on, you. Here we go. These pins here, I had to flip it for the PT1000 that I'm using. So if you are using something that's not a normal thermistor, aka like a 3950, I want to say, if you're using something other than that, you want to make sure that those pins are set for the thermistor that you're using. If your board has that capability. I want to say this board does have the max 3185, or I think that's what it's called, max something. It does have that chip on here to be able to handle those 31865. Yeah, so it has that on there to be able to handle a bunch of different thermistors. So if you are doing that, make sure that you're setting those pins appropriately, or your hotend will not work correctly. I do like that we get to use multiple tools, and I'm being smart ass when I say that. I wish I could just use the same thing for everything, but those do need to be button heads so that we don't have it stick out too far. Alright, so that should allow me to unplug the motor here. Okay, there's that. This extra wire, again, I was using this for the cartographer, and so that had to plug into the tool head board directly, which is here. So I just had it plugged into the CAN high and low because I was running CAN bus on it. So I had to make up this cable. Normally this would just pull directly off. You have all your connections here. But if you're running an extra CAN device, like a cartographer or some other accelerometer or whatever, and you want to use CAN, you will have to make your own cable to be able to fit onto these pins here. I wish those were integrated here. Maybe add another 4 pins down below and then update the board to correspond, but we're not there yet. Unless somebody knows how to custom make that stuff. I do not. Okay, so just pull out all the hardware that we were using to mount this. Pull out that PTFE tube. And that's in there. I'll have to come back to that one. I did print the frame that has the lightened. Mine looks a little different. This is the lightened version of the Galileo 2 by EZ something. The name of the designer escapes me, but they removed a lot of plastic from the frame and the print itself. Doesn't matter. I don't know, maybe it's 3 to 5 grams lighter because of all of the holes in savings in the plastic to make it lightweight. I just like the way that it looked, and I had no issues with it printing or being solid at all. So if I look at that frame and then I look at the stock frame, you can definitely see the difference between the two. I thought this one looked better, so that's what I used. But until Filaments, updated updates it to this, I'm gonna use the stock one. You'll never see this anyway behind your stealth burner, but I knew it was there and it made me happy. Okay. Not quite related, but might as well throw it out there for suggestions. SVO8's been popping out a message saying bed not reach set temperature even though it is at the set temp and heat soaking. Still continues and doesn't stop, but popping up the message is concerning. JPP, look at PID tune. I know that you probably did that. This is not your first printer, but that's where I would start. I would PID tune it again, and then if that was not working for me, I would maybe check the thermistor, because if it gets to temp and it's sitting there, but the printer is still yelling at you, that sounds like a thermistor issue. So that's what I would recommend. Oh, this one here. So this vertical stack, I found that on printables to be able to run the cabling down. The way that my, how to say it? The umbilical strain relief that I have on the Trident is a little different than what Seabor had recommended. They wanted me to use something that goes through, it's almost like a cable chain, kind of like the Bamboo has on their cable chain. And it came with something similar, but it was really messing with my input shaper. And so I removed that, found an umbilical mod that I like a lot better that doesn't impact the input shaper in the same way. But the problem with that is that the normal Galileo 2 strain relief was not going to work, especially using the Big Tree Tech board. So found this guy. I think I remixed it a little bit and then mounted it on here and it seemed to work. But really now that wire comes up, it goes down here. Oh, sorry. Yeah, it comes up, comes down, and then it goes in through the bottom of this and up and across to the back of the printer. So that's a lot of extra wiring and whatnot. It's not as clean as I would like it to be, but it's really the only solution that I could find at the time. It's probably due for a better remix than that, but we'll get there when we get there. Your LDO Trident is not stock. I don't know that I have a single stock printer over here. Let me think. Yeah, I was gonna say that the switch wire I built a couple of months ago was not stock, but was stock, but that's not true. I definitely modified that with different. I used a Manta in it instead of the E3 board that came with the kit, and then I also. I'm trying to figure out how to do this. And then I also, what else did we do? We did a different hot end on it. I didn't use the Revo Voron. I think I used a Dragon or something like that I had laying around. The Revo Voron will work. Oh, that's right. I used a PZ probe. That's what it was. PZ probe instead of the traditional Revo. Ooh, and then I got this too. I'm gonna show you this. I just thought about it. This is what I want to put on there. This is not official. It's a Revo heatsink using a Hamara heat break that's threaded. So that allows me to use almost any sort of heat block that I want. So I'm not locked down to the Revo ecosystem. Man, that's hard to say. Revo ecosystem. So what I did is I got this CHC Volcano hot end from Triangle Lab, and it uses a plate heater that's a lot wider than the standard Bamboo version. The heater wire part of that does seem to be a little, flimsy. So I'd be careful with that portion. And then it runs a Volcano nozzle. This is a 0.5 Volcano CHT. So all of it's clone, but I mashed all that together. And I want to put this in a Reaper and run a Reaper on the switch wire. So that's the plan. That's what this is reserved for. Maybe we'll do that on stream, maybe I won't. It just depends on how far we get with this box turtle business. Hey Shrimp Father, thanks for coming in. We are tearing apart the Galileo 2 right now to swap over to Filamatrix. Yeah, a little bit of shading in there, not too bad. But Boothie, this is why I like the Galileo 2, man. Look at that gear set. That's a huge gear set on there. And then on this side, this is the part that I don't like. It's a smooth bearing idler. Focus. It's a smooth bearing in there. That's the thing I don't like about the Galileo 2. Maybe that's why you were running into some issues too. Is that bearing is just not applying enough force for you. I'll tell you one thing, I am not going to go through and remove all these heat sets out of here. Heat sets are, what, $5 for 100 of these things? It doesn't make sense to spend your time, unless you want to. There's no way that I'm gonna do that right now. Not saying I'm gonna throw these parts out. I like to have them as spare, so I'll probably keep these parts in a parts bin. If Filamatrix doesn't work out and I need to just use the printer, I can just disconnect the box turtle, throw the original Galileo back on, and then put it back on the printer. Try to reuse this tube though, if I can get it out of there. Just can't grip it. It's so slippery like it's supposed to be that I couldn't pull it out. All right, and then we got to get this bearing out of here. I know that's in there pretty snug. I remember putting it in and have to put some pressure on there. But how do I get it out of there without destroying the part or marring up the bearing too bad? Neat custom Franken hotend. Yeah, not my idea. I saw that Heart K had done something like that. And I was like, ooh, I got those parts spare. So let me do that. Yeah, I was talking about using the PZ probe on the switch wire over there. Boothie can attest to this, but I had a lot of issues trying to get that thing to connect. It was very finicky. It would trigger early, all kinds of things. I tried playing with all the different sensitivities, making sure things weren't too much vibration. Ultimately, the solution that I found that worked best for me was to have a pause in there. So like it would home and then it would pause for, I want to say, a half a second before it did the next move. And ultimately that was the solution that I found that worked out. So what I just did is there's a small hole in the back of this thing and it allows you to push that pin out. And so I just put those tweezers in there and push that pin out. Same thing over here. There are two small holes down where this bearing is. And so if you were to come in from the backside, you could push that out with a tool. But there's also two, I guess, grooves in either side of the retaining spot. And those are where I just put in some tweezers and pried out that bearing. So if you're looking for how I did that, there you go. We'll save those old parts. These are the new parts. And we'll just kind of reverse what we did, but we do need to do some heat sets first. So I'm gonna put all the small bits where they need to be over here. We'll probably have to bring up the manual for this, because even though I'm taking it apart right now, I definitely want to make sure that we're putting it back together correctly. And I don't trust myself, so if there's a manual, I'd rather use that. Okay, old part there, new parts here, old stuff. Let's save and reuse that. And I want to flip over to the manual because I want to say that we reuse all of this. Maybe this arm changes. I'm not exactly sure, so gonna flip you guys over to the manual real quick. And we'll do that. And I'm not sure why we're showing both here. Let's see. Turn this down like so. Why are we showing both? That's weird. That is weird. Let's do that. No. Strange. There we go. Let's do that. Got it. All right. So this is the manual, and it's for filaments, excuse me. Regular steel print. So it's filaments, JPP. Filaments. Filametrics is a different thing, and it is not correct. You want filametrics. This one here. And if I come into the home menu, so this is where you would go if you're at Armor Turtle XYZ. You'd see the box turtle and the fidget in both versions of the turtleneck. I have the original turtleneck done, and it just uses 2 end stops to determine what is where. The 2.0, we do have parts for the 2.0. It's the smarter version of the 2. And so maybe we get to that at some point, maybe we won't. My goal today is to get through Filametrix. This is the manual for that, and it does tell you that you can go over to the original Stealth Burner manual to get more guidance if you need it. And it talks about differences and whatever for the build that you're doing. Same settings that you would use for your original box turtle, all the same file name rules as before. And then we get into where you should put heat sets. So we'll do a few of those real quick. Cat ear version of Filametrix? Probably there seems to be cat ear versions of a lot of things. I don't understand that. I guess people like that aesthetic, and that's fine. It's not for me. I won't be doing cat ears on anything. We got the soldering iron warmed up, ready to go. We'll drop in a few heat sets as soon as we clear the desk a little bit. All right, bring this in. So this one is the one that I got from Amazon. This is not a stealth press or any of the open source ones. I got this one for I think $20, probably less than that, on Amazon about a year ago. So when Stealth Burner was brand new and before they had kits that are easily available, I found this thing. It's just a few extrusions. It even came with the soldering iron and a few of the tips that you need to be able to press in heat sets. It's adjustable. Just undo the screw, undo the upper screw, and that allows this whole thing to slide. You just cinch it down, and now you have a spring action that you can use. Very, very simple, and I use it a lot. What if Brittany says she wants cat ears? Then Brittany can build her own Voron and put cat ears on it. That's what I would say. All right, so they have us doing heat sets in here first. And let's see, let's verify. One in the bottom, and that's to have a good surface to be able to cut with. So we'll do that. And then you have 2 kind of more up the top of the face there. And this is definitely showing me the Clockwork version, not the Galileo 2 version. So we'll have to flex and go to a different. We'll use the Galileo manual. It's roughly the same though. Heat sets are pretty evident where they go on Voron parts. And having built this recently-ish, I can figure it out. But I'm going to take you over to the Galileo 2 manual just to make sure we're good. If I could type today. Let's see, Galileo 2 GitHub. That should be it there. And they should definitely have a manual that we can view. Manuals and extruder. Yeah. All the same stuff as before. You can see that information on the same Armored Turtle stuff as we saw previously. Cool. Cool. We have some settings in there for clipper. We have a exploded view of what everything should be. And I know that some of the parts are different. We may have to go over to Thunder Keys' version to be able to see, but it does give us a good picture of where those heat sets go. So we'll make sure that we add them all in according to this picture here. All right. Good morning, Jeremy. You did not almost miss it. We're gonna go until at least we get this built. We are taking the Galileo 2 extruder off of the Trident to my left, and we're converting it over to Filamatrix. That's the goal today. So we got the iron warmed up, ready to go, and we're dropping in heat certs right now. Probably should have did this last night, but these parts got printed late last night, and I was not awake when they finished. Stream's been running good. Normally, the issues that I seem to have are audio based, and I think updating the PC, we did a little bit of a tour of the new stream setup. So looking at the new PC and the new monitor, and had the camera flipped around and all that to take a look at some of the updates. But I think that's the ultimate change, is probably don't use a Microsoft Surface to stream with unless you are doing it purely for gaming and you're streaming in less than 1080p with a single camera. Just one man's recommendation. But thanks for all the help yesterday. It's kind of more like I want to say verifying what I thought I already knew. So we had a lot of those things set up already, but a experienced set of eyes looking at it to tell me if I was on the right track was super helpful. So I appreciate you. Just verifying which ones we need to do. Let's get you guys a good view here. Sorry about that. There we go. Right there. Oh yeah, we got it. We'll just keep smiling, keep dialing, baby. All right. And yeah, this thing, super affordable. Don't worry about building a stealth press, printing out all those parts, unless that's your jam. This thing works great. It's got V wheels on here, so easily adjusted, tensioned. Comes with the soldering iron. Like, I don't know how you beat that deal. This is the weird one. This one on the side was always the most difficult. You have to balance the part while pushing that in as straight as possible. So what I do is I get very low on the desk to be able to see that, and then I'll just use my tweezers to make that flush. Been using a backup laptop for streaming since your main laptop is down. Can notice it's struggling. Yeah, so if you were here last week, JPP, we started streaming and then had to stop the stream twice just because of the new camera was pulling so much data that it was causing the processor to freeze on that surface. And it was making the stream laggy, it was making the audio choppy. It was absolutely terrible. But this mini PC is super affordable. This one, I want to say less than 500. I want to say it was like 460 or something like that. But it's got a really decent processor in there. It's got enough RAM and everything to handle what we're doing right now. Like the press, link to the press later. Yeah, of course, I'll share it with you. And it's got that very solid base too. So the very same or similar base to this guy. And I know you got one of these because you gave me the link for this, Boothie. But very similar base to this, so it's beefy. The base on this guy weighs about a pound. This one probably 3/4 of a pound, so maybe half kilo to put it in English terms. But yeah, it's been good. So, and then we have two on this side here, and we'll do that fitting up top. Normal MSI 8 gigs of RAM. Those are rookie numbers. You got to pump up those numbers. What did you say? This, yeah. Yeah, this one's 32 gig. And you can update that. I think it'll go up to, I want to say it's capable of going up to 64 if you're really running intensive tasks. Still do imperial weights? What? Booty, I'm a fan of using metric for almost all things. Millimeters make much more sense than the imperial system we use for length. And then for weight, the kilograms are a little bit more difficult to understand, I think. Stone, definitely. I have no idea how you convert that around, but it's a thing. Yeah. And I don't even know why we would even still use stone for anything. Okay, so I do have some of those ECAS fittings left over from the box turtle build itself that came in the kit. I think these are to build whatever hot end you want to install it on. And I had, what, 1, 2, 3 left over, 4 left over. So we're going to use them for, we're going to use one of them for this. Only been decimalized since 1972. Yeah. I don't know anything about 1972. Except that you were decimalized. And if I think about it, the library uses the Dewey Decimal System. When I buy a container of anything from the store, it's usually listed in liters and gallons or quarts or something like that. So if I'm going to use both systems of measurement anyway, I'd rather use the one that makes sense. And for length, meters make more sense to me than using inches and quarter inches and 30 seconds and sixteenths, and those are a lot. That's a very nice click. It's a very nice click. And I do need to put a few, looks like end stops in here. I don't know that I have a 5.5 millimeter ball. I think the one that I have is a 5. It's up here, just happens to be up here. Found this one on the floor the other day. When I bought I bought a box of these. I bought them in a pack of 100, and I want to say I bought them as 5s. But as soon as I picked up the box out of the Amazon packaging, it went all over the floor. And I spent the next 20 minutes picking up small steel balls from the floor, and it was fantastic. Let's see, I can use this. So this is my no clogger. If you don't have one of these, consider it, I guess. I'm not saying it's a perfect solution, but it works for things like this to make sure a filament path is clear. And I can see that it's moving that ball. So it's there, and I pull this out, and the ball goes away. So that tells me it probably is going to do what I need it to do. I'll just need to make sure that it triggers enough of the end stop to be suitable. Stone is easy, throw in the river and be done with it. Yes. I think yesterday we were talking about this and somebody suggested they use pebbles. I thought that was pretty hilarious. One of the fans died on you, and that laptop, they are mounted under the heat pipes, so I have to take it all apart to swap them and redo the thermal paste. Or just get a different laptop. I hear the framework laptops are pretty good. They are a little pricier, but they're infinitely upgradable, just like a normal PC would be. I'm seriously considering one of those for the next laptop that I get. Just got the mini PC, so it's gonna be a while before I invest in anything else substantial. But framework, I hear, is pretty good. Framework is great. You have one, Jeremy? I saw that when I was talking to Luke at Rocky Mountain last year, he's the one that turned me on to it. I was asking what laptop he was using because he was doing CAD or something on there. And I'm thinking back to my poor little Surface where I can't get basically Onshape to work. And he told me about it and gave me the link and whatever, and I checked it out, and it's kind of been on the dream sheet for a while now. I just haven't gotten there. All right, I'm going to try and interpolate between what I'm seeing in the Filamatrix manual and the Galileo 2. So we just made that front face. For the most part, the only thing different about this one and the Galileo is the location of the heat sets and the picture of the part itself. But the intent is the same. The back plate we don't have for a Galileo 2. It's an all-in-one extruder type of thing. So I'm going to skip this one. But we do have a small lower portion. So I'll flip over to this manual. We did all of these already. This small portion is already done. That's on the original Galileo. So I've done that part. And let's see. Yep, and so we've done this part as well. This is the part we need here. So you have that one there and then one on the side. Hey Digital Dragon, thanks for stopping in, man. Hey, quick question for you while you're here. Did you use a Galileo 2 on your Dragon Burner build for your extruder, or did you go with the recommended Clockwork 2? I'm testing fate, and I'm gonna go with the Galileo 2. I understand it's not the recommended per se, but when have we ever done anything recommended on in this garage? Just got to be able to hold on to things this morning. I'm like super jittery. It's been a tough week. I know it's been a tough week for a lot of people for a lot of different reasons. Said you've always used Clockwork 2. A lot of recent serials ago. Yeah, Thunder Keys, I think it should work. And by the way, thanks for being here. I think it'll work too, but you recommended specifically that people use the Clockwork 2. I don't fully understand why. I'm hoping, since you're here, you can kind of tell us why you like that one versus the Galileo 2. I prefer Galileo 2 when I'm doing anything stealth burner, because for me, I just like that it grips a little better than the Clockwork 2. I've always had issues with the Clockwork 2. And that could totally be me and using limited skill sets initially when building and just not doing it appropriately. I'm a lot more skilled now than I was when I built my first Voron. Filament path on Galileo 2 is less consistent, reliable for automatic. Is that because of the smooth bearing? You have to get the tension precisely right. So there is a way to tension the Clockwork 2. We had a question earlier in the chat on how would you tension it, because some people were claiming they get slippage. And I thought it had something to do, losing the steel here. I thought it had something to do with this tensioner here. I just tighten that down. But Boothie, who's in the chat, was saying that no matter what he was trying, he could not get this to work. And so he went back to a Clockwork 2. If we end up having to do that, I will print all those parts and we'll cover it on stream. But I hope to not have to. I'd much rather use the parts that I have instead of trying to rebuild something new for a second time. I know that goes in there. And I know this goes in here. Ooh, that's a nice snap. And it comes out. Fun. Yeah, so both heat sets on the end and on the back side. Clockwork 2 is unfairly maligned as an extruder. It's also way easier to service. No malaise over here. Clockwork 2 is just fine for what it was at the time. And I just think that for me, I prefer the way that the Galileo works. I like the way that it kind of functions as far as tensioning, and I'm able to just press this over instead of having the snap latch. That snap latch always felt not secure to me, and so I like the tension method on this one a little more. And again, I think that's just preference, not that one is mechanically better than the other. I do wish that there was a dual drive gear on the Galileo 2 instead of like a smooth bearing, but here we are. Included in film metrics so people have options, and it's good to get feedback on other builds as well. Yeah, I appreciate it. I think that's the goal here, man, is to do different on this channel. I could totally just do the same thing that everyone else is doing and follow the line, but that's not how I am authentically, and so I don't want to do that on my live stream either. So we're going to continue to try to do different stuff, only because that's what I like. And it's my channel and I get to build what I like. Somebody was saying something about, oh, you're just a poor boy, so have to window watch. We'll get you there, JPP. Reach out to me, tell me what you need. We can do some things. Yeah, hit the like button. Hit the like button. Clockwork 2 seems to work more consistently with the box turtle. Well, I may be eating my hat. We'll see. Hey, Thunder Keys, I was just looking at your manual on the Armored Turtle XYZ, and I didn't realize you guys had dropped the manual in here until yesterday afternoon. So thanks for dropping it in there. This is more work, and I'm not specifically requesting it, but it would be nice to see the Galileo version in here. You're probably already thinking about it. Sorry, let me flip you over. You're probably already thinking about putting the Galileo 2 in here. But if you're not, it would be nice if you get time amongst all the other random things that you're probably involved with on this project. I'm skipping a lot of this because it doesn't really matter for what we are building. So I think it's more important to be on this manual. And that's where we are. Closing some windows here. Got some things in the background. All right, we're gonna reuse that part from earlier. So really we just made this front face. Just check that. Should be good to go. I know I had a drill bit somewhere over here. Don't exactly know what I did with it. We'll find it later. It did seem clear when we ran the no clogger through it though. All right, so put the pin in, and I have a pin, so we'll do that. This is the pin that we used earlier. That just goes down inside of there. And then this is the idler portion that we used earlier as well. Idler goes on pin like that. And then this lock, or whatever you want to call it, goes on top to hold that all together. And then there's a screw. And then there's a screw that keeps it in place so you don't do what I just did. Yeah, there's a small screw that will go right there. And it's a M3x8. I think I used, because I'm looking at it over here, I think I used a button head, because then also I needed to, when we put the breakout board back on there, it uses that same hole. So maybe it's a M3x8 right now, and then when we put this on later and assemble this, it'll use a button head. I think that's how I had it. So I'm going to pause on using that. Bring you back over here. That's what I was talking about. And then we had the bearing, so we've already done that part there. We'll go ahead and download this manual so we don't have to. It's just not pulling it from. Not pulling it as it should. Been considered, but these manuals are a ton of work. That's why I said it's not a hey, go do. It's a it would be nice. I only say that because you guys do recommend it as an option. If you didn't, I wouldn't even mention it. They are a lot of work. I would love to help you out if I can. Let me know. Let's see, getting ready to make blueberry pancakes, bacon, and expensive ass eggs. Yeah, that's like $42 in eggs just to make breakfast every morning. I think pancakes have like $8 of eggs in them. That's more than gas right now. You'd love to build a turtle box? It's called Box Turtle Wheel. You're gonna get fried in the chat for calling it a turtle box. But no kit in Canada. I think Sparta 3D might have kits. Double check me, but I want to say they might have kits. And I've never heard of a Quattro box. So if you can send me a link for that on Discord or something, let me know. I've never heard of a Quattro box, and I'll check it out after stream. Let's bring up this manual. So I know you can't see what I see, but I'm looking at the PDF on the side over here, trying to get down to where we were. Just want to make sure we build this right. We've done the idler. We've done this one here. No turtle box allowed around here. Yes, absolutely. And then we did the screw. We've already done the ECAS in the top. The collet's already in the top of the extruder plate. And then as you assemble the extruder, we're already good on all of that. Here, we already have that built from before. We're just going to reuse all of it because they had to eliminate a lot of chickens. Yeah. Yeah, bird flu is real. Protect yourselves. Still good through the pin. Yeah. So now we're just slapping this bad boy together. So this portion goes into this portion like so. Pin side goes through the bearing like that. And then we just connect that together with some hardware. When we all go on vacay together? Yes, we are going on vacay together, and I'll buy the eggs. How about that? If you make breakfast, I'll buy the eggs. I didn't put that heat set in here. I think I should probably do that first. Of course, it's not mentioned in the manual because the manual is for standard clockwork, not the version we're building. Thunderkeys, if you're still in the chat, I want to say you guys had that in the manual for what is it? The Filamatrix. I think you had that in there. All right, so we're doing this. Yeah, so you had a heat set there. The part I printed has space for the same, so I'm going to add that in there because that has to be right. It makes the most sense. Yeah, and I think it's the same size. There's not like a different size for it. I hope not, at least, because I don't have any other sizes. If I look at that manual, go back a few to the beginning of this. It just says M3 heat set insert. It doesn't say anything smaller. So we're just going to press with that. Move this back up. Keela, you can cook for us only if we have turkey bacon. And then we'll make Jeremy eat it. All right, so now we have our heat set that is flush. I use the plate to both cool down the plastic and then also to make sure that things are flush. So that's what I'm doing when you see me doing this. If it's hard to get in there, I'll use the flat side of the tweezer to do the same thing. All right, this keeps falling apart, but we should be good now. So that goes there. This goes in like that, and then this all screws together. Get him to convert. We just won't tell him. He won't know. He won't know. All right. I built a few Clockwork 2s. This is the one we're working on right now. I want to say this is the 1, 2, 3. 4, 5, 6. This is the 6th boron, 7th boron. There's a delta over there. This is the 7th boron that I've built. 6 of those have had clockwork from the start. I much like and prefer the assembly of the Galileo 2. So, for what it's worth. All right, so that goes that way, and then we could start doing the normal things like putting this board back in here, getting the arm on. Oh, that's weird. I missed this part. It's not covered in the manual at all. I gotta figure out how this goes. I think it replaces the original. It looks like it does. So we'll take this apart real quick. I totally missed that. Luckily, it's only 2 screws. We'll just take that apart. Here, let's move this out of the way. We don't need this anymore. And reclaim some desk space. Put that over there. All right. We'll just undo that real quick. Try not to drop a bearing. Yeah, I try to work down close to the desk. So if I do drop stuff, it doesn't fly all over the garage. All right, that's that. This comes back out. There's another bearing there. Sweet. All right, we're gonna have to redo this arm here. So that means 2 screws. And put those where they should be. Try to have a good habit of keeping track of the hardware. Less bounce. Yeah, less bounce. And if it does bounce, it doesn't go far. If I'm working up here and I drop, it has a lot more bounce and it usually ends up behind me somewhere or under something. And there's so much stuff off screen and elsewhere around the garage that it's going to be lost for days. Let's see. Okay, so this is the part I'm trying to figure out here. This is definitely a plunger type. I just don't exactly know where it goes. It also looks like there's some sort of I think I put this is the cutter portion. I think I put that in there like so. I don't know how to secure it though, so I'm gonna have to figure that out. Hey Reth, thanks for stopping by, buddy. I need to come see you guys. We had talked about that last time I was up there, and it's been months now and I haven't been back. I apologize, man. I need to come see you and hang out and just talk shop with you for a little while. Probably gonna need that iron back. We'll press in this last heat set here. Something like that. And we'll press that in. Super glue helps secure the blade. The holder is held into place with the arm with a 2.5 by 16 screw. Okay, thanks for offering that up, man. I appreciate it. What I'm trying to figure out right now is so this is what I got. I got the extruder. This is the normal tension arm. I can't really remove that because it serves as a one-piece component for the entire frame. You're always home, don't go anywhere. That's how I feel too, and that's probably the reason I haven't came back to see you in a while, is because I'm always home. And by home, I mean working and or home. There's really no in between lately. But we just got finished doing, to go off on a tangent a little bit, for the last 2 months, I've been planning a 300-person award ceremony for my entire organization. So 300 guests, and I had a team of 8. And over the last 2 months, we had to plan this thing. Execution day was Friday. Thursday was setup day. So starting Thursday, I was over at the venue for 12 hours on both days. I came home to eat dinner. I had a couple of hours with the family, and then we went right through sleep and back at the venue. So It's been a crazy couple of days. It's really nice to be back in the garage working on stuff. The arm attaches to the hot end duct, not the extruder. Got it. Okay, so I don't need to take this apart. Or I'm going to build this like normal then, is what I understand. And it attaches to the hot end duct. So this portion here. I see it right here. So as I put that together, it's connecting right there. I see that now. Yeah, Keela, it sounds awesome. It was a lot of work. It's a lot of work, shoestring budget, all of the normal challenges that you face when you do anything big like that. But I'll tell you, I feel like I could plan Rocky Mountain now. That's a joke. I would not want to plan something that huge at a off-site venue like that. But roughly the same level of pain, I want to say. So pin goes in, shooter back together once more. Hey Reth, I think you had built a box turtle, right? I know you got that tool changer out there that I was admiring last time we saw each other. Still want to do one. Maybe not a stealth changer. I do have a different style of tool changer over here. But I think I saw something in the Discord that you were building a box turtle, or you had built one. Now that you've had time to use it, what are your unfiltered thoughts on it? Let's see. Do not make me block you. No turtle box. Who's saying turtle box? Did I say turtle box? Oh, Jeremy said turtle box? Oh, turkey bacon? I don't know what's happening right now. I just see things on the screen. I'm trying to keep track. Alright, so we're snug on all that. Turkey bacon is also... okay, I'm tracking now. Somebody's saying TB. Turkey bacon. Got you. I think I messed up. Maybe not. Do I need... Thunder Keys, do I need another... one of those super tiny bearings down inside there? No, that's the filament path. But I will need 2 of these steel balls. Can you verify that these are, what is it, 5.5 and not 5 steel balls, millimeter in diameter? Because I don't know that I have 5.5s. I think I only have 5s. They might work. I don't know. Let's see what we have in the drawer of things and stuff. Yeah, I really don't think I have the 5.5s. These are all 5s. Yeah. So I've got this box of 5s. Yeah, we are dead in the water on that one for today. I'm gonna have to order some 5s. So it's funny. I've got those 5s, and then we have these 10s. It makes no sense. Yeah, thanks for sharing the link, Jeremy. It's fine. Share links to useful things that I do not mind. I just don't have the bandwidth to share links, as people are asking. Let's see. G2E Filamatrix only comes with 2 sensor version unless you talk to Schlonky. Only need to load 1 though. Okay, so I don't need to populate both. I don't know the history of that, why there's 2. Is that for the tip forming portion, or I still need to have the bearing in there? There's not a bearing in the top spot here. And the slot in this bottom one looked like it was the filament path and not the not for the bearing. Yeah, that totally looks like the filament path. There are 2 for happy hair. Got it. That makes sense. I do have an ERCFA, but why do that when box turtle is a thing? Unless you like pain. Or you want to do it for the gram. Okay, so we'll pause here on the extruder. I'm not going to be able to finish that today without the correct balls. I'm going to have to order those when they get here. I'll put this together off stream. But we can swap over the hot end. Which sensor needs to be used? Yeah, that's a good question. I don't know that it matters, but my initial thought is that I'm going to use the top one because it does have the slot for the wiring, which is much cleaner than trying to run it down low and under the board and then back around to try to plug in at the board. Get the bearing out of the ERCFA kit. I could do that. I don't know that I need the bearing, Boothie. I think I need the 5.5mm ball, and I don't know that ERCFA has a ball in it. Happy hairs for ERCFA, Night Owl, and potentially Boxer. Reth, I want to build a Night Owl. I think that's what I'm going to build for my Micron, is a Night Owl. Yeah, I had a lot of extra hardware for this one. Let's see, you still need to have the bearing in there. You do, otherwise the filament path is not constrained. What bearing? I'm not seeing a bearing. AFC is also for Night Owl. Yeah, AFCs are like hen's teeth right now, though. They're hard to find. ERCFA kit has a 5.5mm bearings. Yeah. When you say bearing, are you meaning steel ball? Like a ball bearing? Because my American brain, when you say bearing, means, you know, the round bearing that I would put in this position. Yes? What did I do with my ERCFA kit, though? That's the thing. There's so many things around that finding my ERCFA is hard. Let's see. I know that I have a container full of box turtle parts that I was using for self-source. I wonder if I had purchased those balls. Not in that one. Not in that one. You can tell I like Big Tree Tech a lot. Yeah, that's always fun. Maybe it's this container. So I have 4 containers up here, and it's not always apparent. This is the right one. Okay, this is like a lot of the self-source stuff that I got to build a box turtle, and there's some other odds and ends in here. Let's see, these are 148s. It's extra parts. Hey, I printed these for Valentine's Day. Put those over there. I have no idea what that is. Got more motors, so we can build another box turtle. Connections for something. Yeah, I don't think I had ball bearings in here, because I do not see them. Just seeing hardware, like screws and steel shafts, some BMG parts. No ball bearings. Oh, actually, here we go. What size are these? I think these are, yeah, so these are also 5mm. Outer diameter 5mm, number of pieces 10. How did I order so many of the wrong thing? That is frustrating. If you say there are 5.5mm bearings in the ERCFA kit, I'm definitely going to need to find that pretty quick so we can get back on track. You guys bear with me here. I've got stuff kind of everywhere. Let's try to find an ERCFA real quick. Let's see. In the meantime, you guys keep chatting about whatever it is over there, turkey bacon and whatever. And let's see if I can find this ERCFA. I don't even know if that's how you appropriately say it. That's how I say it. And it makes sense to me. There's just so many different projects out there that it's hard to keep track of all of them at the same time. And in particular, with filament changers and whatnot, thanks Bamboo for ruining all of it. Everybody wants a AMS and a filament changer as I drop stuff all over the floor. Yeah, so I'm looking through my junk pile of things, trying to find this kit, and I have no clue where it is. But I did find, I'll bring this over and show you guys. I did find something I think is pretty cool. I found a bunch of Nighthawks. 1, 2, 3 Nighthawks. Did not have an ERCFA, we just thought they did. Okay, so we don't know. I don't think they do. I'm looking for it because I don't want to throw away a good idea. And if I can use stuff that we already have without having to order more, I'd rather do that. But I don't recall that the Enraged Rabbit carrot feeder has that in it. I know if I had a a filament sensor for like an Orbiter 2, if I had an Orbiter 2 filament sensor, it would have that. But the only ones that I have are already installed on printers. So I'm not gonna cannibalize another printer just for a 5.5mm ball. So in the spirit of time and staying on track, I am definitely just going to skip this part and come back to it, I think. Come back to it off stream at some point. Unless I'm lucky enough to find a kit that I was looking for that has a sensor ball in it. I did get, what is it? My brain escapes me. A Prusa i3 kit, and we were gonna update it. And I want to say that had a ball in it I could steal. But again, I'm not exactly sure where that ended up. Here we go. Found it. I think the parts are in here. I hope the parts are in here. Nope. Okay, well, not to waste anybody's time, we're gonna come back to that. I'll order some and we'll proceed on a different day getting that squared away. So I'll build that off stream as soon as I get that stuff sometime this week. I got all my time back now that we're not LDO sensor on the Zerabo. Yes, that is true. I could steal it out of there. Let me see. I don't think it's too hard to take it apart. And there is a sensor on it. There is a sensor on it. There's also one on Vivo over here. But Vivo works, and I don't want to make it not work. That's the challenge that we talked about every time, is like, I'll get this really cool thing, and I will build I will build and get curious and try to modify, and then I break the thing and the thing doesn't work anymore. So what I'm doing is I need to rebuild this Prusa anyway. Thanks, Breath. I'm going to steal it off the Prusa because it's right behind me. And it's a little more accessible than any of those things. And I dropped something just now. Of course I did. And if I can take it out of here, that would be a lot better. No, this is an optical. It does not have a sensor ball. That is unfortunate. So that's not going to work. That was a good idea for a second. And yeah. Anyway, not wasting any more time on that. We'll come back to it. All right. So maybe I will take it out of the Zerbo after stream or something. That thing hasn't worked in a while. Maybe I'll steal it out of there. I don't know that we ever accounted for which of these it would be going with. Sorry. Let's see. I'm trying to catch up on chat, sorry. Ball bearings in the bottom sensor. Is that the one that we recommend here? Using the bottom sensor? AVP would be happy with people building night owls. I will build a night owl on stream, Reth. I need to do my micron and rebuild that from scratch and update to the newest parts and whatever. So I'm very keen to get started on that. There's just so many projects in the works. I need to decide which one I want to do. Top sensor is best. Okay, we'll use the top one. That's the one I was thinking, just simply because it does have the wire control here and it looks like it goes right into where I need it to be. So I'll plan to use the top sensor with a ball that is appropriately sized. I think in the meantime, I'm going to chance it and see if this 5 will work. Because again, if I can save some time to not have to do that, that would be best. Let's see. I'm looking at all these Prusa parts up here. And I really feel like I had some 5mm. Just don't know where they are. All right. Let me find a filament sensor here. I have some that are already soldered. And so that's what I want to use, is the one that's already done, so I don't have to worry about making more. Soldering is not hard, but a little bit of a pain. Especially if you don't know where all of your filament sensors are. Yeah, so I bought some sensors that have some pigtails on there, and that way they could just plug them and go. But like most things, I did not keep track of where I put them. Seems to be a theme. Just exactly when you need something, they're not around. Because I'm not very well organized. That's okay. We can pull out of this tray. We'll get some of this going. So we have a bunch of sensors that we can use. And we'll just do a bit of soldering here. Let's find some wire. Let's see. I've got some 26. Got some 26 down here. Gotta look up the Night Owl. Not heard of that one. Yeah, Night Owl is one of those GitHub projects that that works well. It uses two what are they called? Night Watch extruders, and they just kind of bolt in, and it's a lot more compact of a design. So I got this giant spool of wire from AliExpress. I think these are 10 meters each, and they're all FEP wire. and they are, I'm trying to see the gauge on here, all 24 gauge. Yeah, I've got some 22 over there. Silicone, it would probably work a little better, but these are pretty thin. So that's 24. It's also 24. I thought I got different sizes in here. Yeah, it's 24. Let's see. I'm gonna cheat and use the camera. Can you guys see on there what it is? See if I can pick it up on the screen. No, it's too shiny. I think this all might be 24. Oh, this is 20. That's too big. Yeah, we'll just use the 224s that we have here. We'll save the rest of this wire for later. That's enough wire to do an entire printer. You just found the Nighthawk. Good. That's great. And if I'm using the upper sensor, I can go ahead and just put this in. I don't have to worry about that lower one. Let's do it this way. Let's put that in there. This is my longer button head. I think this is a 10mm button head to get into where that idler was. Anything else was too short for me. And then I have a much shorter 6mm for the upper screw. And just tighten that down. Fits just like the old one. And I'm using the upper port here. This is it's labeled the fan. Using this upper fan port as my end stop. But I do have this other end stop pin, or I'm sorry, port here. And I think I'm going to use that one for this. Because right now my X is plugged in here. This can be for the tool head end stop. Thermistor, and then I'm not using the probe port for anything, and I'm not using this port here for anything. So we still have capability on this board for other things if we need it. Let's plug in the motor while we can. It's easiest to do it here on the bench than trying to do it in the printer with everything connected. So I usually do the motor first, and then we can add in our standoffs. I'm just going to use the same ones from before with the super long hardware. This one goes there, like so. So I'll just go ahead and put that on the screw, and then everything should bolt together like that. Yep, and that's how mine's gonna go. I think what I did is I had to make this portion here. I don't know that when I modified all this to work together, that the original part was long enough. I think I extended this one out. So if that is true, I will drop that remix on printable somewhere if someone's trying to duplicate the same setup. All right, and then this one goes up here. PID tune and SVO8 was probably the fastest you ever had. Did that end up working for you? Was that the problem the whole time? Was your PID? Yeah, run it again. Run your SVO8 again and see if they fix the problem for you. All right, all back together, just like it should be. We do need that sensor in there. We'll get to that here in a bit. I want to finish swapping over these parts from the old hotend duct to the new, while keeping track of the hardware. I want to use this. I like using JSTX H5 pin connectors. I want quick connectors on the switches. It's not as reliable long term as solder though. What switches? I'm trying to interpret what you're talking about, Rob. I don't know offhand what you mean. You're talking about these here, these connections? The sensor. So the sensor in this tool head though is just a 2-pin. It's just a 2-pin clicky in stop. So I'm not sure what sensor you mean. That's why I'm confused. I'm sorry. But I love tips and tricks. That's why I'm curious about it and asking you about it. I was looking at Canon plugs and stuff last night for this box turtle. I know it's only running CAN, but I'm looking for a clean solution instead of just running a wire through the skirt. 3-pin solution. Yeah, I'm probably only going to use 2 pins on this. I'll use the 2 outside pins because that's normally what we do. And so it'll just be a 2-wire. And then it'll have a, I think it'll have a 3-pin JST that comes with the board. I still got those laying around somewhere because these are not normal JSTs. These are a little bit smaller. And so they got to fit in there. So I'll use a 3-pin on this side, but I'm only going to use 2 of the pins, populate 2 of the pins. Why are you not coming apart? So strange. I don't want to force it because I don't want to break it, but it's like stuck together. I don't think I glued it. That would be dumb. Maybe it melted together? Yeah, it did. It melted together a little bit. That's fine. I didn't realize it got that hot. But yeah, it melted to the thermistor wire a little bit. Try to pry that off of there. Here we go. So we'll save that guy for later. Again, just in case we need it for something. We'll hold off on those parts and we'll use those for other stuff. We can put this door back on. Actually, we'll save that. That way we have access. We can see what we're doing. A couple more heat sets here and here. I don't do the accelerometer heat sets because I don't use the LDO accelerometer down here. I do prefer to use the one that's on the board itself, and so I use this one. Also on this machine, there's a second accelerometer. There's one on the cartographer, and you could use that one as well. So it's just unnecessary to have 3 accelerometers on one machine tool head like that. It's unnecessary to have 2, but they're both built in, so I'm not going to add a third just because. We'll see if we get to making some end stops here in a second. I want to get the easy stuff done before I get into the tedious stuff. Let's snip that off there. Okay, so 2 heat sets for this guy. More ADXLs the better. I mean, maybe. Maybe. I don't know if you're joking with me or not. I can only do one at a time. And then can I, like whatever the results are, I can't input multiple sets of values. Can only use the one set of values in Clipper. So what would I do with the other set of values? I am pretty sure they would be different based on location. On the tool head board, it's much more rigid than down below on the cartographer would be, or even if you had like a nozzle sensor, you're going to get different readings at each one, correct? You can read multiple at the same time? Yeah, but how do I can read multiple and I can run input shaper on multiple, but I'm saying like the values that I get out of those graphs though, can I put multiple values in the graph? Or I'm sorry, multiple values in Clipper that can be used? Different based upon the location, however you get more pretty graphs. Yes, I get more pretty graphs. And then I call you to figure out how to read them. And I think I told you this before, but your videos on that subject are super helpful. They're kind of the go-to when I want to understand what goes on. The closer to the nozzle, the more accurate. Kind of. You gotta think your nozzle is, so let's use this as the example, and we'll put this in here. Your nozzle is at the end of this long effector, or sorry, this long lever. So if I put an accelerometer here, but my rigid mount is up here, this is going to be very rigid, but this is still a lever. So you could get some movement and some wobble here at the end of this. Whereas if I put that same accelerometer up top, now this is much more rigid. It's also more at the center of mass. And so I could expect it to be significantly different. Now, what matters is, does it matter? The values that you're going to get, are they significant enough that it's going to impact your prints? And for me, this is what Reth would call unicorn chasing. You can go all day and try to perfect this thing, but if you don't see it in your prints, in my opinion, it doesn't matter. Why would I spend all that time and effort to do a thing that doesn't even register in the prints that I'm printing? Right? And at some point, you're going to hit limitations of the machine itself. And so you run down the rabbit hole of, now I'm looking at trying to buy better rails. I'm trying to buy more rigid x-axis. So maybe I go from a carbon beam to a super heavyweight beam, but then mass decreases my speed. It becomes a rabbit hole of things. Thanks for the backup, Reth. I paid attention in class, your class specifically. I'm seeing a third heat set on here. Is one of those for the... It sure is. So I do need to put a third heat set right there so that when we put this together, I can put that cutter arm on it. So I'm gonna use this upper hole for another heat set. And then it looked like there was a flathead cap screw that went in there. These parts are taking a little bit longer to get warm before that heat set goes in, and I just remembered that I printed them out of PC blend. So these are made from Pruchiment. PC blend. I used the last little bit of black that I had because I was completely out of black ABS. All the colors of the rainbow in ABS over behind me on the shelf, no black. I don't know how that happens, but it printed really nicely. Decent overhangs, and I just printed it with standard PC settings. I didn't change anything. So it gives the message on the Clipper console, but it reaches and stays at the proper temp and goes past that message. It doesn't appear like anything is wrong. Perhaps there's something in the blank. It's gotta be macros. It's not a red error, just a message in the console. It's annoying, and I would want to fix it myself. I get that aspect of it, but realistically, if it's not stopping you from using the machine, it doesn't really matter. I don't have a good answer for you on that one, though. I've never seen that myself. That's why I said normally I would default to PID tune and or something going on with your thermistor. I don't know anything about the SV08 other than its semi-Voron-ish style, and that it's pretty decent for what it is, for the cost. What I don't know is if there are spares available for things like thermistors on the bed or whatever. Like I said, I don't own one. Printing fine, just a tad concerned, but same as you, it doesn't appear to be an issue. Yeah, I would not worry about it, man. Yeah, the hot end is not particularly lining up as good as I thought it should. I'm struggling a little bit here trying to get this to go. So what I'm seeing is the rotation on this. I gotta rotate it this way, but because the thermistor and the heater wires are sticking out the side, it doesn't want to rotate. Halo sync. So I wonder if I need to take this apart, take the hot end apart and rotate it so that it will fit. I did need to do that on the original to build it into the previous fan ducts. And so maybe they're not in the same position that they would need to be for this one. That's all I can think of. But yeah, the holes on this are just not lining up unless I am rotated here. But then I got the wiring sticking straight out the back, and I don't think that works. It might work. It's running a CNC hot end, so it's not a problem that they stick out the back. I think I'm gonna just go with that because I really don't want to take this apart. But now I wonder if like the wiring is long enough if I do that. I think it should be. We'll find out. I'm very much a just go with it, and if it doesn't work, we'll redo it. So Low Sync, what are you working on today? We are taking the Galileo 2 and Stealth Burner apart and preparing it for Filamatrix. I am going to continue to use the Galileo 2, even though the recommended version is the Clockwork 2. This is what I had installed previously, was the Galileo 2, and I just want to reuse the parts instead of rebuilding something new. And so we're just getting down to the part where we're doing the ducts to be able to put it all together. So we already built the extruder back. I did miss the size of the steel balls that go in here. These need to be 5.5. I only have 5. So we'll have to come back to some of that. You're doing a new tool head on the Merc. Which one? Are you doing the Eva or are you doing the new Rat Rig one? I had 2 Ender 5s at one point. One of them I converted to Core XY project by Boothie, who I think is still in the chat. He has a project out there where you can convert an Ender 5 to Core XY. And then I was going to save the other one and do a Merc build. And I got the kit from Fabrico to do that. But in our move out here to California, I decided that I would just never really get to that project. And so I sold it off. And I never did a Merc build. They're interesting. But I really prefer a enclosed printer. So everything that I do now has to be enclosed, or I don't really want to build it. Or it's got to be able to be enclosed somehow. You're going from Eva 2.4 to Soul with a metal carriage. I like that. I've got the XOL sole. I have that on the thick framed V2 over there that we're calling Vivo. Again, another Boothie project. Converts a hypercube into a V2.4. So he and I built those kind of at the same time. He's always quicker than me. He's got more time than I do. But he's got the first two. That mine is number 3 over there. And it's a 3030 framed V2 that uses the same exact gantry as any other normal V2. So if there are specialty parts or new idlers that you want to use, they will all convert right into it. The only real difference is your Z connection needs to be for MGN 12, simply because a 3030 frame has to use a 12. MGN 9s are too small for that extrusion. And that's where I put my XOL at, is on that guy. Just making out some room here. I like to make sure these holes are clear, so I'll just take the 2.5mm hex key and I'll throw it in there and twist it around. That'll give me enough room for any hardware I try to put through usually. Requires new XY joints. Probably because it changes the location of the belts, yeah? Is that why you need new XY joints? And while we're at it, I'm gonna cut this PTFE. This is a part that comes in the kit when you download all the STLs for the conversion to Filametrix. Make sure that you print out the correct jig for whatever hot end you're using. This is the Rapido Ultra High Flow. If I can make one tip, label it, just write on there like kind of like this. Use the same lettering scheme they use on this one here. Come on, focus. Use the same lettering scheme on the side of the tool, so that if you're printing multiple or you download the whole packages, that you make sure you get the right one. Again, just a tip. Heard? All right. Thanks, Armored Turtle, for hanging out. You guys are, Armored Turtle, you guys are doing great with this, by the way. I love this project so far. It's a little more involved than just building something and plugging it in. There's, you know, you're basically building a printer, because, yeah, you have the whole hardware side, you're building all the extruders, but then you still have to flash firmware, you have to connect it. Then you still have to build a tool head to go with it as well. That tool head needs to be able to have a filament cutter on it. And then you have to make sure all of that works. So it's pretty involved, which is what I like. So I am more than happy with the project so far. It's just like little tiny things that, quality of life wise, that are probably personal preference. So thanks for hearing me out. So when I took this apart, I did not heat the hot end. Again, the firmware was messed up. I could not control the printer. I did not heat the hot end to be able to get the filament out of there. And this one little piece is still like lodged in the hot end. It's preventing the PTFE from going in like it should. Hey, Steve Builds, thanks for coming in. I'm going to catch your stream here in a little bit. We're building a Filametrix today, but I'm using the Galileo 2 versus the Clockwork 2. So a little bit different. And then we're running the Rapido 2 Ultra High Flow. So pretty straightforward build. No manual for this one, so I was kind of fumbling through it. And we forgot to get the correct size steel ball bearings. So somehow I ordered 5mm and not 5.5. And so now I have 100 useless ball bearings. That's where we are. Going to be doing a couple Merc builds coming up after Murph. Why not do it before Murph and bring one with you, JPP? That way we could all see them at Rocky Mountain. Not useless, just haven't found a use yet. Good point. Not useless. I need to find the right project. Print a giant bearing to put your five. That's one way to do it. Just add an attachment to the bearing that makes it 5.5. You know how hard that would be to even get that to print correctly and operate right? Lazy Susan for the workman. That's a great idea, actually. I might jump on printables here after stream while trying to catch yours, and we'll finish up this and check out an option for a Lazy Susan. Steve, so this is what we did. I did a dumb. So inside there, barely see that. I left a piece of filament. The printer's not working, so I couldn't heat up the hot end to remove the filament. So I just cut it off, not really thinking that it would be a problem. But now it's preventing me from getting this small piece of PTFE in there. Lesson learned. Lesson learned. A 1/2 mil shim, chamfer a piece of PTFE. Yeah, so that's what I just did. We had the chamfering tool out here. Let's see. So we get the chamfering tool out. I like this one. I don't know what you guys use, but I use one of these. I got this, I don't know, with a filament subscription. I don't even remember. But it works exactly like I need it to do what I need it to. Why does Susan have to be lazy? We could call it a Lazy Patrick if you like. Or a, what's the funny term? So I heard the other day, uncouth Joseph, which is another word for sloppy Joe. I think chamfering kind of works, but it's not going in as far as it feels like it should. So I'm just going to take it apart. We'll put the PTFE in first, and then we'll put the hot end on. We'll do it in reverse. Steve, are you continuing with your box turtle build today as well, right? I think you're much further along. You're about to start printing, I think. We still have to do firmware. I need to rebuild the firmware on the Trident that this is going to go on. Somehow it dropped Clipper, it dropped all the things, and I don't know what is wrong. So I have to rebuild probably the entire image on that thing. It's just not wanting to take Clipper at all. Hoping to be the last stream. If this is the last stream, that means this is the last time you get to get a box turtle giveaway on the stream. So if you guys in chat today want to win your own free box turtle, you have a chance over on Steve's stream to do so. I would not be upset if you go and support that lovely gentleman and win yourself a box turtle. But I'm hoping it's me, if I'm honest, not you. Not to be mean, but I do hope it's me and not you. Did I cut that too short? I feel like I cut that too short. That went all the way in there. And it should stick out a little bit, right? This should technically be flush. Or is there a heat insert in there that I missed? I'm gonna run and look at the manual really quick. There is a heat set. Thanks for confirming. My gut told me there was, because I do remember during research yesterday seeing that there were kind of, I'll call them dueling heat sets where they pressed up against each other to create that smooth path. And I missed it. So we'll add that really quickly. So that explains the short PTFE. So it's pretty funny. My youngest wanted to come out here today and help out. Yeah, thanks, Ref, for confirming there. We just added that. My youngest wanted to come out here and help stream today. And I told her no, because she gets excited. She's very loud, and she would create a lot of distraction for me. She tries to help. Her heart is a heart of gold, and she truly wants to come out here and help Dad build things. But she often takes the tool that you need, the hardware you need, and then you're looking for it. So I told her no, but I can hear her over there at the front door right now. Hey Dad, are you done? Can I come out yet? She's so cute. She came out on one of the earlier streams a couple of weeks ago and said hi real quick before her mom came out and got her. But yeah, watch his cats build the box turtle as he assists. Kinda, yeah. Steve, I don't know how you do it, man. I'm not a cat person. I don't necessarily hate cats, but I'm more of a dog person. I couldn't have somebody or an animal like climbing all over my stuff while I'm trying to build it or whatever. That would be frustrating to me. But good on you for having the patience to deal with something like that. They are cool though. I really enjoy that aspect of your streams where you have your cats come out. All right. Assembled again for the second time. There is that heat cert there. That makes much more sense now with the PTFE pushed all the way down inside the Rapido. And now there's a smooth transition path. So if I take my no clogger, I can push that all the way through there. That piece of filament is still in the way, but it does go down into the PTFE. So that's a nice touch. Don't forget that like I did. And then I really like this too, Thunder Keys, that you made this a one piece to mount the hot end into it, and then your fan duct back part goes on that way. I may modify some other fan ducts to do the same thing. I like that a lot more, being able to do this that way. And then I'm just trying to route all the wiring here to make sure that things don't get pinched. That would be bad news bears. All right, there we go. Should I, for those that have built this, should I go ahead and put this arm in here now before I tighten all this down? I think I can wait on that. I still need to order the blades anyway. And I do remember Thunder Key said there's a 2.5 by 16 that goes through to hold the blade carrier. So I'm thinking I should just wait and add this later, because it feels like I can still put that on after the fact. So add that to the list of things. We need 5.5 millimeter ball bearings and one of two options of blades. Trying not to cross thread this heat set. I think the one on this side maybe is not absolutely straight in the hole there. That's cool. We still got 9 people hanging out today, many of which have already built their box turtles. I'm super behind the curve here, but your help is certainly appreciated, keeping me on track over here. All right, so that looks to be correct. I don't think that sticking out of there, excuse me, I don't think that sticking out of there is going to be a problem. The only thing I'm slightly concerned about is that the wiring may be too short now. Well, we'll find out here in a second. Let me take you back to the printer. So taking you back to the printer, well, like before, we'll run some wires to get this thing all good to go. Let's move this back and get you focused. Okay. This will go on like so. And then we'll throw back on our cartographer. I don't have any MMU things yet, so you're still ahead of me. Yeah, well, Box Turtle's still kind of new. It's only been out a few weeks. Unless you built a beta build. I got a lot of parts for a beta build and then never got around to doing it. So they had released the official project before I finished my beta. And so now we're just playing catch up. I don't get a lot of time over the last couple of months. Like I said, I did plan that huge event. Plus I work a full-time job. So many of my days over the last 2 months have been significantly long. I'll say it that way. Upwards of, average day was about 11 hours. Some days over that by a really big margin. And it's been fun, but I'm glad that it's over. If you've ever planned a big party for a large amount of people like that, 300 people, that can be a nightmare. Luckily, things went smoothly. There's always going to be hiccups, right? You're always trying to solve crises the same day as the event, and that was no different for us on this one either. But we got through it and learned a lot, made some connections, expanded our social networks a little bit, and no complaints. So now that I know what to do on big stuff like that, those are skill sets I can take forward and use in other places. Just putting that thumb screw back in here so I don't lose it and I don't forget it. It feels about the right tension. Is there anything else that you could build with an ERKFA V1 parts kit? I mean, you could likely repurpose some of those parts for things. I can't think of anything off the top of my head, JPP. Those ERKFA kits are specifically put together for an ERKFA. So if you're not building that, I don't know. I mean, I know that there's bearings in there, there's motors in there. You could reuse heat sets and things like that. So the hardware you could probably reuse elsewhere, but a specific project does not come to mind. J Terry 3D, it is an all-wheel drive Trident with 9mm belts. We did a little bit of a walkthrough on it earlier. Let me turn a light on here. I'll give you another quick walkthrough of it. Sorry, I'm using my, it's a dark cave inside here. I think if I just move these panels, maybe get some more light in, and that should help us. Let me move this out of the way. There we go. Took me a while to figure that out. Put those panels elsewhere and get more top-down light. There we go. That's so much better. Should have thought of that like 3 hours ago. But yeah, it is. So you have normal AB motors. So B motor here, A motor other side, and then the opposite. So A motor here, B motor on this side. It does have 9mm belts. This is a Seabore Trident. Because of who's in the chat, we'll call it a Quad XY. But you may hear it incorrectly referred to as a all-wheel drive Trident. It's great that it's all-wheel drive and all that. That's specifically why I got it. But even more so, came with CNC parts. So the XY joiners are CNC. The bracketry to hold the motors is CNC. You also get these braces that come with the kit. These are CNC'd. It came with backers. It came with a side blower that you can kind of barely see the duct here. So it does have a side auxiliary blower fan. Came with 5160's Manta V2 board. All of the wiring that you would need, all the motors you would need. One thing that I added to it was the Mandela Roseworks bed arms. So those are CNC'd now instead of being printed. I wanted to keep all things CNC. I mean, if we're gonna go there, let's go there, right? So I did add those, and it's running an easy bake frame. So if I move this camera manually here, stick with me. It's an easy bake frame, which means the rear extrusions are 40-40. So 40 mil across by 40 mil across. Really stiffens up the back of the frame. The lower portion of the frame where this comes down and connects to is just out of frame, but it's a 20-20 extrusion. And then these front extrusions are also 20-20. So these here are also 20-20, which means the gantry is actually inset by 20mm. So I could attach things here if I wanted to and have it come inside. So if I wanted to put some drop light here, just create a little bracket, and put more of those like daylight on a stick type things, I could do that on this internal extrusion. But I do have them up top, as you could see. I have them up here. So if I added them here, they would give you even more light if you wanted that. Hey, Clown Hammer, thanks for coming in late. We're getting to the point where I think we may wrap up here in a bit. We rebuilt the tool head here for Filametrix so that we can run the box turtle on the Trident. So that's a little bit of a tour of the printer, and if you notice real closely, you can see that back here, this is the Doron Velta. So the unofficial Delta printer for Voron, passion project from Roger. Just trying to maneuver myself here. All right, so it does look like the wiring is going to be long enough. I was a little bit worried about that, but for no reason at all. So the thermistor goes in. I like to trap as much of the wiring as I can behind the thicker wire just to keep things tight up against the board. So I like to plug in my thermistor, and then I like to do all of my end stops, and in this case the cartographer wiring as well. That way I can sort of hold it in there with the other wires and create a nice package. So that will go there, and so the port right next to it, let me get a pointer. Let's see, what can I use? We'll use this. So again, if you're just joining, we're going to use this port here for the Filametrix, the one behind the X end stop, and that'll kind of run across the front, and we'll have an end stop sensor here. I just don't have the steel ball I need, so we'll get back to that one off stream. The CNC mounts are nice. Yeah, CNC mounts are super nice. It makes the printer super rigid. It also makes this printer heavier than a normal Trident, specifically because of the frame, but also the CNC parts do add mass and do add weight to the printer. And anytime you can increase the mass of the machine, you're going to generally get better resonance results. Reth can tell me if I'm lying or not, but generally you're going to get better input shaper graphs with a heavier machine just because it can tolerate a lot of that. And I just realized I did another dumb. I need to route this CAN bus wire through the... originally I had it behind the board, but I think I can get away with putting it in front of it on this go. And I think I did that because I need to access this heat insert here. Sturdier frame, not necessarily heavier per se. Yeah, that's probably a better way to say it. Sturdier frame. And if I use a 4040 extrusion and 2040, it's going to be more sturdy than a 2020 alone. That's a better way to say it. You're correct, sir. All right, so we'll do it that way. And then as I connect that and push that back, this wiring is going to want to move out of the way. Not worried about it riding on the belt. I just want to make sure that when I bring this tool head over, it doesn't pinch, and it doesn't. That triggers on the X before it pinches the wire in there, so that should be good there. It's not my favorite, but it's the best that we got right now. And then I like to take this wire for the hotend heater and just kind of hold the other wires up against the board and plug that in. And that's how I do it. And so then when I close that door, it holds it all in there tight and pretty neat. Not a lot of wires go to this anyway using this tool head board. It's just the end stop, the thermistor, and the heater. If you were not running a cartographer, you wouldn't even have this. So it'd be even more clean for you. But yeah, I'm a fan of the tool head board. I prefer a NEMA 36 board like a Nighthawk or something like that. But for this particular build, that's not what we're doing. All right, this gets to be the tricky part. So we have to plug in the cartographer at the same time. We don't lose all the screws. So I'm gonna just take all those out because I already know that they're gonna go flying. All right, so we'll plug in the CAN stuff. I know how my wiring is wired. I know that black is always ground because I prefer that. Red is always positive. And so I'm just connecting there. On this particular one, I like yellow for CAN high and either green or white for CAN low. On this machine, I'm using white for CAN low. So when you're doing your CAN wiring, make sure that you take note of how you have that. You don't want to connect them backwards. That's going to cause you headaches. It should not break anything, but it might. And I'm realizing I'm going to need to move the CAN wiring above and come in. Because as I plug that in, those wires are just totally in the way. Let's move this around. All right. We'll bring this out. We'll put it above the end stop. Because the end stop is making it difficult to route things. So that way we'll come above the end stop and try to sneak that in there. I think that's probably why I had it in behind in the first place, is because of that. So we'll do a quick reorg and create some space behind the board to route this wire. A little bit of a pain. Don't want to drop it though. Got it. That never happens. I always drop that thing. It falls down into the Zyltech stuff, and then I lose it in the electronics bay. Got lucky today. All right, so we're gonna sneak that behind the board. I had to take out the other one. I thought I could get away with just loosening it, but not today. I'll just take that all the way out. Try not to drop this one too. All right, Kegel. See you, buddy. JPP, see ya. Never saw someone connect their CAN on the faceplate. Yeah, so I'm doing that because it does run the cartographer, and I could run CAN all the way from the tool head, have another cable going back through and then down into the electronics. You could do it that way, but there is CAN access on the back of the board right here. So I'd much rather run a shorter wire right to these 4 ports that I already have open. So that's why I'm doing it. It makes the most sense for having clean wiring and not to have this gigantic umbilical out the top of the machine. Again, the more umbilical that you have, the more vibrations you're going to introduce into the tool head, which I think all of us these days want to reduce vibrations as much as possible. So through clever thought processes and wiring, you can get around some of that. You're always going to have vibration, let's be honest. These are printers. These are not highly calibrated space age machines necessarily. All right, I think I'm good with that. Yeah, so before I had these wires behind the board like they are now, and that worked out. And then I moved them. I thought I could get away with having them in front, and I just can't. So they're just getting snagged on the pins on the back of the board here. So there we go. We'll do it like that, and we'll put these screws back in here real quick. Yeah, pop away. All good, man. There is a cartographer on here, and you could also use it for, I think the what's that thing called? The 3DO nozzle cam. I think that runs CAN. I don't know. I don't have a nozzle cam on any of my stuff. But yeah, you could use it for anything that you want to run over CAN. You could do. Nah, I was gonna say an accelerometer, but I think those need multiple pins. But yeah, if there were another item that you wanted to connect to CAN bus, you could use those pins for that. I mean, honestly, that's probably why they're there. I don't work for Big Tree Tech or their design team, but I mean, it makes sense that they would put them there for this reason. Cool. Let me just plug that back in like so. And as I turn that around, you can see that wiring kind of folds where it should be. You just want to line up those pins on the daughter board and give it a little tension there to put it together. Let's bring this forward. I can't really see. Like so. Well, not like so. What are you doing? All right, so all that wiring should be flat. And what I did for that was I heat it with a heat gun. So I have, I'll show you guys. Bring it back to the desk real quick. So I have a heat gun like this right here. And what I do is I'll heat those wires until they're pliable. And then I'll put the faceplate on and just let them cool. So I'll just let it sit there 10 minutes, and they tend to kind of form into the shape as they're pressed together. So they end up in that like swooping motion, and when they get pressed together, they stay where they're supposed to be. But you got to heat them first. I don't know about you, but my garage is not heated, and it gets cold out here. So if I try to work out here in the wintertime, kind of like right now, these things and their wiring don't bend as I would like them to. And if you have ever unboxed a new, I don't know, widget that has a USB cable, they will fold those things, and they'll fold those cables, and then they end up all like crimped, and they have bends in it that you can't get the bends out. So if you want a nice flowing cable, warm it up with a heat gun. Be careful, you don't want to melt it, but warm it up with a heat gun. Put it in, what are those things? Like if you've ever had like a heat pad or a heated blanket or something, you can put it inside there if you're worried about melting things with a heat gun. But if you do that, warm up the cables and straighten them out, it'll keep it where you want it. All right, so that build was not too bad as far as that portion goes. It would be better if we had the correct parts. We still do need to put the lever arm on, and we need to do, what's it called? The rigid mount on the frame here, so that it has something to trigger against. We got to build that. And as far as I know, it works with steel backers. This portion here is a steel backer, so I do have those, and from what I remember yesterday, the holes do line up, so it's not prohibitive for your setup. So cool, that's that, and that came out just as clean as it was before. So if you're trying to do this, don't worry that you're gonna have to make a ton of changes. This mod and adding the Filamentix to this was not that difficult at all. Now this is the part that I did not like to do, was I had to run, so you can see I had to run the cable down, tuck it up against the tool head itself, and then up again through that wire relief, that tie down point there, the comb looking thing, and tie it like that. And that's so that when this tool head goes backwards, it doesn't press against the A motor or the B motor over here. I do have this arm that holds my cabling. That is kind of in the way. I do need to redesign this to push this backwards. Part of the problem is that I'm using a 2040 up top. Like I said, this is an easy bake frame, so it's a little more beefy, which means it takes up more space as well. So I do need to redesign that, and we'll get there eventually on this build. But yeah, that'll go like that with a couple of zip ties, and that thing should be good to go. I don't want to install those now. I do need to take this off again and add that add that ball inside there, and then run the wiring for the in-stop. So I'll get to that off stream. We've been going for about 3 hours today. That's usually the limit that I like to do, simply because I like to get on with the day and free you all for your day. So I think we're gonna call it right there for today. I appreciate you guys hanging out and talking with us and guiding the project a little bit. It's been really cool to have people that have built box turtles come by and lend their expertise. So I really appreciate this community hanging out and let me know. Kayla, sorry, I'm just getting to your messages, just getting caught up here. But yeah, it's been a good build. Box turtle's done. Let me grab that. So this is the box turtle here. Throw this back on the desk. And give you this. And one more, take you back to the desk. So this is the box turtle here. We finished this last week. This is the mechanical build portion of it. All right, Booty, we'll see you, buddy. So this is all done. I cleaned up the wiring a bit. I didn't cut any of the cables that I thought I was gonna cut. I may still get to that eventually, but I'm gonna put a bottom panel on here and it's gonna be hidden, so I don't know. But yeah, box turtle build went great. We just did the tool head. I think next week we'll get into firmware probably. And once we get into firmware, that's when the trouble is gonna happen. It always happens on firmware. It's usually a problem with some setting or something in there. So I need to rebuild the firmware on the Trident anyway so that I can even flash the AFC light. It does work with backers, yep, tracking. And I have those parts. I have those parts printed already. I just need to decide which of the two we're going to use. Yeah, any other questions before we call it for this Sunday? Blue TPU, I think look good with the black and white. It was all that I had. I would prefer them to be black. That way we keep the theme. There's nothing on this printer that is blue. So using blue TPU was a pain in my heart. It hurt me very deeply to use blue on this, but I used what I had. It's either that or pink. And so blue was already open. I used blue. But thanks for being nice about it. I do like it though. I'm ready to go. I want to use it, but we got a lot of firmware to get through. I'm gonna try to get a lot of that done on stream. I don't want to keep dragging this out. I'm ready to move on to another project. So we're gonna finish this one up throughout the week, hopefully, and then next week's stream, maybe we'll have it working, maybe we won't, or maybe we'll move on to something. I think I don't know, I'll throw it out to you guys that are left. You get to pick what we do next for the next project because you chose to stay around. You have the option between starting the Rat Rig VCore 4 build. You have the option of doing the Doron Velta and finishing that out. It is mechanically finished. It just needs some firmware and some buttoning up. So we can look at that. That's probably one stream worth of content there. Or we could do something crazy and, I don't know, figure something else out. But you all know where I'm at. You're here every week, so we talk quite often. Give me your thoughts, what you think we should be doing on stream after we finish the box turtle. I'm open to suggestions. But thanks for hanging out today, guys. That is my Sunday. I'm going to join you all over on Steve's stream. Please go over there. Please go try to win a box turtle. It is a fun build, and good luck to you all, okay? So thanks for hanging out. We'll see you on next week.